Hello friends, welcome to the mathematics video lecture series. We were discussing complex number, and in the previous lecture I discussed about the algebraic operations that can be operated on complex number, and we covered almost all the topics. In this lecture I'll be discussing about modulus of complex number. So it's a big topic, so let's start. Modulus. Okay, so modulus basically means uh, absolute value or magnitude of a complex number. Again, let me compare it with vectors. In vectors, if you know that any vector has two important quantities. One is the magnitude, other is the direction. Okay, similarly in a complex number, when I say modulus, I simply means the magnitude of the complex number. If you remember, any complex number z equal to a plus ib is represented on the arcane plane as follows. This is the real axis, this is the imaginary axis. So suppose this is the point A, this is the point B. So the complex number will be this line z1. This point A comma B. So you join the point with the origin. This line represents the complex number. When I say modulus, the modulus is represented by the mod function. Okay, so if I say modulus of z, that means mod value of z. This mod value of z is nothing but length of the complex number. Okay, so this length that you are seeing, this length, this arrow, this length is known as the mod z. Okay, so since this is length, so mod z is a real number. It can never be imaginary. Length can never be imaginary. Length is always a real number, and it is also positive. It can never be imaginary. It is always positive. Okay, so if you see, if I ask you what will be the length of this line, so using Pythagoras theorem, you can say that this base in this right angle triangle, this base is A and this perpendicular is B. So this length will be nothing but A square plus B square whole under root. Okay, so that means for any complex number, z, mod z is equal to under root of real part of z whole square plus imaginary part of z whole square. This is equal to mod z. If you remember in the previous video lecture, I told you that z into z bar, multiplication of z with its conjugate, is nothing but real part of z square plus imaginary part of z square. If you compare the two, what we get? That z into z bar is nothing but mod z square. Z into z bar is nothing but mod z square. This is another very important identity. It's used extensively in complex number problems. Another thing to remember is that please, z square is not equal to mod z square, because mod z is a real number. So mod z square is also a real number, it is always going to be a real number and a positive number. However, z square need not be real number. In the previous lecture, I told you that z square or z cube or z to the power 4 can be easily found. Z square will be a plus ib into a plus ib. This will be a square minus b square plus 2abi. So if you see, it has a real part and it has an imaginary part. So it's a complex number. But mod of z square is a real number. This is telling you the length, and this is squaring of the complex number. So please, whenever it is given that mod z square, don't replace it with z square. Or if in the question it is z square, don't replace it with mod z square. This is wrong. Please be very careful. Okay. Let's talk about properties of modulus. Properties of modulus. So first is that mod of z1 into z2. So there are two complex numbers z1 and z2, and I am multiplying the two complex numbers, and then I am taking the absolute value of the resultant complex number. Okay, this is equal to mod of z1 into mod of z2. Very important identity. So you can multiply the individual magnitudes, and that will be equal to magnitude of the resultant complex number. Okay. Similarly, mod of z1 by z2, this is equal to mod z1 upon mod z2. Two very important results. You can try to find out, you can try to prove the expression on your own. We don't have time, we cannot prove it in this lecture. Okay. Third is that mod z1 plus mod z2 is not equal to mod z1 plus mod z2. So this modulus is, you can distribute it over multiplication or division, but you cannot distribute it over addition. Similarly, mod of z1 minus z2 is not equal to mod z1 minus mod z2. These two expressions are wrong. Okay, so very clear that mod of z1 into z2 is mod z1 into z2, and in fact you can extend it. It's not just that this is valid only for two complex number. Mod of z1 z2 z3 zn is equal to mod z1 into mod z2 into mod z3 into mod zn. But in division you can not divide n numbers, n complex numbers. Okay, because if you divide, it will come to the numerator. So it's no point. Okay, so for the division we write it simply mod of z1 by z2. Okay, these are some very straightforward thing. If I ask you what will be mod of I, so mod of I is equal to 1. Magnitude of I is equal to 1. Okay, so what will be mod of I square? Mod of I square is nothing. We know I square is equal to minus 1. So this is mod of minus 1, which is equal to 1. Okay. There are some further results that you can use. Mod of minus z is equal to mod of z. So whether it's a negative number or a positive number, it doesn't matter. If you put a negative in front of the complex number, it does not change the magnitude, because I can write mod of minus z as mod of minus 1 into mod of z by using the distributive rule. This will be mod of z. Okay, so these are some of the important results of modulus. Okay, and in the next video lecture series we'll